Okay, so we looked at the core interface classifier. So here we have, and that was a behavioral aggregate classifier. Here we have a firewall classifier, and the twist here, as we've mentioned before, that's quite similar to the other example. The twist here is that even though it's a firewall filter, a firewall type classifier, we're actually reading the DSCP values. So in a sense, it's operating a little bit similar to a behavioral aggregate, but as a firewall filter, we could be looking at anything in that header. It's relatively simple. From the DSCP best effort, it's going into the forwarding class VPN, and everything else is going into VPN priority. And we're attaching that on the interface. And this is designed to grab traffic from the customer C3. So this will be applied to that C3 interface. Okay, so this is our class of service based forwarding. The idea here is that we're going to be selecting traffic using a class of service, and then we're going to be directing that down an LSP, and so therefore we're class-based forwarding. So how are we going to do it? Well, we're going to be creating a policy statement and then attaching that to the forwarding table as an export. And of course, as traffic's coming through the forwarding table, it's going to flow through that map or the policy statement, which will do the action that we want, which is to class-based forward. Okay, so from the top, we're inside class of service, we have a forwarding policy, and the important part here is this statement next hop map, because it allows us to create this map connecting various forwarding classes to LSPs. Then of course, we have a policy statement. We're going to be, we'll call it CBF map. Chosen the same name, but it could be different. And from a particular route filter, we're going to apply the CBF map. And then we attach it to the forwarding table as we discussed. What's it going to do? It's going to take traffic, it's going to select it, and it's going to push it down a particular LSP. So finally in this example, we've got a couple of policers. We have a hard policer and a soft policer. Now the hard policer clearly is going to discard immediately, whereas the soft policer is going to change the packet loss priority, but not immediately discard. So it can be discarded further down the line by something like random early detection. Okay, so how are we going to do it? Well, it's a little bit similar to a committed information rate and a burst size. We've got a bandwidth limit here, which is effectively our CIR, and then we have a burst size limit. Now remember that the bandwidth limit is, well, it would be the interface, but in our case that's actually going to be an LSP, and that's set to 60 meg. The burst size limit, we're using a formula here, which is basically the bandwidth of the interface, or the LSP, multiplied by the time that the burst exists for. And in this case it's 10 milliseconds. Then of course you have to divide by 8 so that you get your answer in bytes and not bits. So 60 meg times 10 milliseconds divided by the 8 is the 75k. So that's the two different policers, the hard and the soft. How are we going to attach those policers? Well, what we're going to do is we're going to use a firewall filter. So here's the firewall filter. We're going to select the policer and accept it. And here we're selecting the other policer and accepting it. And once those policers have been accepted by the firewall filter, we can attach those firewall filters directly onto our MPLS label switched path. And that's how it all hooks together.